My name is Michael, but people mostly call me Schnitzel. That's my Drupal.org username and everywhere else in the internet. I'm the head technology founder and partner of Amaze.io, and Amaze.io is a hosting provider. So we're going to talk a little bit about hosting today, but mostly about COVID-22. So let's look at COVID in general. Well, if we specify COVID or what happened, basically it was all about crisis communication for us from a government point of view. These 6 steps is actually from the CDC CERC, and it talks about how do we communicate in case of crisis. And it starts with be first, then be right, be credible, express empathy, promote action, and show respect. And the one I want to talk about today is really about the really first one, about be first. And the reason is that, as the CDC says, that the first source of communication often becomes the source against which all others are measured. So for us, from a government point of view, we want to be sure that we are the first. But how do we become the first, or how do we are the first, or why is it important to be the first? Well, first of all, citizens need information fast and easy accessible. When something happens, everybody wants to know what's going on, and so that's obviously clear that everybody needs that quite fast. And there are a lot of different ways to communicate. There are super fast things like Twitter, Facebook, social media in general. We can send text messages, we maybe have apps. And then they're all really good to reach out to our citizens in a fast way. But a lot of times these links or these reach out, they all have links back to the website, to your own website. So the website is really the backbone of all the information that is sent out through all the different channels. But people always find back the website where the information actually lives. And so websites are great, and especially .gov URLs are trusted by citizens, they're trusted by the media. Everybody knows that what is written on a gov.url is an actual official data or information, and so that's really good. I think we have a huge advantage there to communicate to a lot of different people that they trust us. Unfortunately, the .gov sites are not known for their stability or uptime. So, and I think that's something we need to work on improving. If anybody remembers this one, the Healthcare.gov debacle, if you search today on Google, you have 3.1 million results about specifically the debacle of Healthcare.gov. And so I don't want to put too much emphasis on this one, but this is an example where, of course, this really hurts the credibility of government websites, and I think we can do something about this. Or another one, New York State, which unfortunately during COVID had to reach out to people and ask them to please not sign up all at the same time for unemployment, but basically based on their last name to sign up. And this was not an enforced system. This was literally just an voluntary system where they tried to handle the so much load on these websites to handle them because the systems couldn't come with it. And so, yeah, we see there's a lot of different ways how to try to handle it, but unfortunately, none of them really works. And of course, this is very hurtful for people and citizens in general. So website uptime and performance is really the king and queen of being the first in crisis communication. And we know that visitors, they're maximum waiting for 5 seconds for a website to load. Anything above 5 seconds, people will either already stop. Facebook actually shows a message that if the website takes longer than 5 seconds to load, it shows you a message, would you like to wait or would you like to close this? So it's really about first-time page views speeds. Then many people, especially in crisis, they maybe get text messages or they find stuff on their mobile devices. So the size of the website is important too, because they're maybe on the road where they don't have a really good internet connection. So it's don't only test your stuff on your home with your good internet, but also test this on the go. And then on the fact that media websites make money with their websites themselves, they're super heavy optimized for speed. And I can tell you, we run a couple of media websites. They try to squinch out milliseconds. Like every millisecond gain that the website loads will end up in more page impressions, more ad revenue. And so these media websites, they're super highly optimized. And so what this means is that citizens, they will get the information where they can get them the fastest, not where they're most credible, where they can get them the most fastest. And so government websites are basically in competition with media websites, especially if they try to inform wrong things. And so, and even worse is outages of the websites of the government cause concern and confusion, and is also fuel for conspiracy theories, whatever kind. And so it's really important that our websites are up and performant at any time. Now, what are possible solutions to guarantee 100% uptime? And I can show you a little bit, at least, what we believe that is required, or how you can achieve 100% uptime during crisis. So the first of all is you need an infrastructure that is scalable. That means an infrastructure that can scale based on the amount of requests that are coming in. Without this, it's going to be very, very hard to survive such an event, because it's very hard, if not even impossible, to predict the traffic that will happen during these crises. And so what does this mean to have a fully scalable infrastructure? Well, first of all, yes, it needs to fully be automatically scalable. It should not be manually scalable. And it also needs to be auto-healing. So the infrastructure needs to realize if something goes wrong, that let's say you lose some infrastructure pieces, that it can automatically heal itself. So that means that manual scaling, which many times today is still the case, that's many times is way too slow. Like, you cannot manually start additional servers fast enough than the traffic that comes in. That also means that your infrastructure should most probably be cloud-based, because clouds allow you to do auto-scaling and auto-healing. And the most important thing, you need to test this. You need to test as good as possible the system to figure out, okay, how does my infrastructure behave on traffic spikes? Because only then you can be sure that you can survive the next one. And besides of having the infrastructure that is scalable, you definitely want to use a CDN. The CDN is for caching, because many of these requests, they can be fully cached, or for bot tamming. We see that many bots take down websites or generate an average load on the websites. And then when the actual citizens are coming, there's less space for all of them. So with the CDNs, you can handle the bots. And you want to have a 24/7 emergency team to handle traffic spikes. And I'm really talking about a 24/7 team. In our case, this is, for example, all over the world. So we literally have people that are 24/7 online, not just a 24/7 emergency phone that then maybe somebody can get up or get woken up, because a lot of times that's already way too late. Until a person wakes up, realizes what's going on, your infrastructure is already gone. So you want to have a team that sits 24/7 and actively monitors the infrastructure and can handle or can react at any time. And it's really important to bring everybody together. In crisis communication for the websites, a lot of times, a lot of information is lost because there's miscommunication or very long communication ways. So bringing everybody together, for example, in a chat where everybody can talk with each other, really helps to have very fast information flow. And that can be done like with dedicated Slack channels. So let's look at actually a case study. So we, as Amaze.io, we run the Australian government's website, or many of them. One of them is the health.gov.au website, which in the past, the last couple of years, never really had much traffic. It's the health website. Like, why would you go there? You maybe go there to find some information about vaccines or things like that, but you never really need to go there a lot until COVID. And so during COVID, and that's a quote for one of their PMs, is that they received 5.3 million hits per day. And they never tested the sites, because usually they receive 50,000 hits per day. So you can see, when we started to have the website, we maybe tested with 10 times more. So we did load testing of 10 times more, because we felt that's a lot. But we now know that this was not enough, and we still survived, which is good. Plus, also the average page load speed remained around 2 seconds, compared to the 5 seconds that we know is too much. So that was really good. And they know that they had 4,600% increase in visitors. So what happened overall? We had a 46 times increase of visitors, which together created around 100 times increase of traffic on the website. we had communication channels with everybody involved. So this means that we had, in this case, these were Slack, where we had channels where the different people were involved that could tell us. And fun fact, we usually got 15-minute warnings. So this is how such a Slack message looks like. So this is one of the project managers saying, hey, for information, at 7 a.m. Australia time, this was posted at 6:45. There will just be a text notification going to every Australian mobile phone. So you can imagine what happens. If something like this happens, you have a link that goes in a text message to every citizen in a big country. This is what it looks like. So this is a monthly graph of the traffic of some of these sites. And you can see that while we had an increase over time, there was a massive spike of at least 10 times during these April days where the communications really had to get out and everybody had to be informed. And that's really what we're planning for. That's what your website has to be ready. It's not just, oh, we want to do an increase of 2 or 3 times. The question is really, are you able to do 10 times? Now, how do we do this? I don't want to go too deep in the technical, but I would just want to show you a little bit of how do we actually handle all of this? Well, first of all, it's completely container-based infrastructure based on Kubernetes. That allows us to scale within seconds. So we can, and the infrastructure actually does it fully automatically. So the infrastructure monitors always the traffic that comes in, and based on that, automatically starts new containers that can be scaled within seconds. So new containers can be added within seconds and handle traffic spikes. Plus, if we need additional resources, so let's say if we need even more than what is at any point available, we can add additional resources if needed, and that takes roughly a couple of minutes. So basically, we can scale the infrastructure to 10 times more if needed within a couple of minutes, which is how we are able to survive such traffic spikes. And it's not only going up, but it's also going down, because scaling up is very expensive. So you also need to make sure that you can scale down again after a specific amount of time, because if the news is out and the traffic's load is low again, you want to remove these resources to not pay for them for a long time. All of this that we know in this specific case in Australia is based on the AWS cloud, where we can do all this easy scaling. And we have a CDN with 90%, 95% or more offloading. What does this mean? This basically means that 95% of all traffic can be handled by the CDN and does not even need to be sent to the infrastructure. And that's really the other one key to use to handle such traffic spikes, because the CDN, which can cache these regular sites, they can really fast deliver the website and make sure that you have these 2-second load times and things like that. And the interesting thing is, during all of this, the editors that actually wrote the health.gov website, they fully could edit or do any deployments during these high traffic events. Because as it usually goes, everybody pre-reads and checks, proofreads all the different communications. Then you send the text message to all the Australian citizens and you realize you have a typo. And then, of course, you want to go in and edit it. And this was fully able. So while all these crazy traffic spikes, editors at any time could go in and change something and adapt, and if there was new information. And this does not cause like some outages or things like that. And of course, all of this is 24/7 monitored and managed by us, meaning that we monitor the infrastructure, we monitor the clusters, and if the scaling events don't work correctly, we can also go in and do manual pieces in it. And like I said, we have people all over the world, meaning that in the Australian night, there is, for example, somebody in the US, in the US-based time zones that is actively monitoring all of it. Now, this, of course, means that if you want to have such a solution, you would need to switch your whole infrastructure. And I'm fully aware that this is not a solution for everybody, or at least will take quite some time. And so I also want to share some easy steps for existing infrastructures. Let's say you have a current infrastructure and you would like to make it more resilient against downtimes of high traffic events. So the first thing I would really do is evaluate the CDN and make sure that your CDN has a roughly 90% plus offloading number. That's the really important thing, because just having a CDN does not make your website automatically faster or more resilient. It's really the piece that the CDN needs to be able to cache at least 90%. The CDN will then protect the upstream infrastructure from being overloaded because it handles most of the traffic. And some CDNs even have functionalities like waiting rooms. So if the site suddenly gets overloaded, the CDN would realize this and will add some waiting room functionalities. Now, I'm not the biggest fan of waiting rooms, and I know everybody else is also not, so it's definitely not the perfect solution, but it's better than having the whole website completely down. And there are these days really good waiting room solutions that automatically show the people when they will be able to visit the site. There is even like possibilities to have text notifications when it's your turn to visit the websites. And it's a bandage to the solution. Of course, we want to make sure that everybody can get the information or fill out forms at the same time, but at least it's much better than having the whole website be down and having like huge issues, like in the case of Healthcaregov. And the other really, really important piece is do load testing now. And don't let your citizens do load testing of your infrastructure during the next crisis, because I can tell you this will definitely not go well. So do the load testing now. There are many, many tools out there that can do load testing, that can handle, that can simulate traffic on your infrastructure. And only when you do these load testing, you can be 100% sure that your infrastructure can actually handle this. And of course, as a service provider, talk to us if you have any questions or things you want to learn, how to be ready for the next COVID that, if we listen to the scientists, will probably definitely happen at one point. So yeah, talk to us and we're happy to help. And that's my presentation. If there are any questions, any things, I'm happy to help. And we see Mark asked, are there specific types resources that you're generally putting on the CDN? So I think I know what you mean, and I'm going to answer in the way I mean, and you can maybe confirm if this is correct. So usually we let all the traffic run through the CDN. So the CDN is running completely in front of the upstream infrastructure. That actually means you cannot directly visit the upstream infrastructure. So let's say where your Drupal or your application is running, this cannot be directly accessed. It can only be accessed through the CDN. And the CDN then knows which pieces can be cached and which not. So how this works is that the upstream infrastructure adds specific cache headers. And then when the request is sent back from the upstream to the CDN to the visitor, the CDN analyzes these cache headers and decides, can I cache this for the next visitor? And Drupal is very good in this. Drupal has support for these cache headers out of the box, and that's how you receive this 90% uptime. So how does this work? For example, the start page of your website that is completely cacheable, so there's no login or nothing at all, the CDN will realize that this page can be cached. The upstream, aka the Drupal, will also tell the CDN how long this can be cached. Is it like for 5 minutes, for 10 minutes, for an hour? And so the CDN will automatically cache this. So in the end, all resources will be seen by the CDN, images, files, PDFs, whatever. It's just based on the cache headers. The CDN will decide, can I cache this or not? Or can I cache this maybe only for specific users and things like that? And so that's how we can achieve this 95 up to 99% cache offload, because we run everything through the CDN. Correct, yes. Yeah, so Mark says, makes sense. So effectively the same process that a service like Varnish would act. Correct, yes. So you can look at your CDN as like the Varnish. The difference, though, of the CDN compared to the Varnish is usually running in your infrastructure, while the CDN is running in all over different what they call POPs. That's individual servers that are distributed all over the world. We ourselves use Fastly as a CDN provider, but there's also others. There's Cloudflare, CloudFront, there's Akamai, and these run all servers all over the world. So even if let's say, I'm a person in the US and I want to visit Australia and I need some information about COVID in Australia, I'm actually talking to a server of Fastly in the US first, which then will forward the request to Australia. And if the server in the US has the page already cached because somebody else in the US visited this, they will then get the information from the US directly. So that's how the CDN works. It's basically a lot of little fast varnishes all over the world that will cache the website for you. Okay, Tish asked, how do you handle certain resources that need to be updated and available to users immediately? Thinking COVID resources here that get updated frequently. Yes, that's a really good question. So we're basically talking about cache invalidation. There is two ways how to do this. There's an easier way and there's a more sophisticated way. The easy way is that you can tell the CDN only cache, let's say, the start page of my website that has the most important information right there, but they can change. You can tell it only cache them for every 15 minutes. That means every 15 minutes, the CDN will send only one request back to the Drupal and say, give me a new version of the start page. So if you have 100,000 people all visiting the start page, only one of them will go back to the Drupal. The Drupal will create a new page with the newest information and it will send it back. That means your data can be max 15 minutes old. But that's already better than having 100,000 people all accessing your Drupal. But it still means you can have 15 minutes of old data. You can also extend this to an hour. You can reduce it to 5 minutes. But the more you reduce it, the more traffic you send to the Drupal or the upstream, and therefore you might actually end up in having a lot of traffic again on the infrastructure, which will then cause outages and problems. The other way, and that's something that Drupal 8 and Drupal 9 support, is called cache tags. And how this works is that basically you tell the CDN, hey, CDN, you can cache all pages, everything you can cache for, let's say, 1 week, or basically endless. But let's say 1 week is a really long time. And then every time that an editor that edits the website, so they add new information to these pages, Drupal will know which sites have now changed based on the content that has changed. And Drupal will talk to the CDN and say, hey, CDN, remember the site that you cached 2 hours ago? It has changed now. And please invalidate the cache. And so the next time a request comes in from a user that wants to visit a page that has been invalidated, the CDN will know, oh, I have my cache invalidated for that. I will go back to the Drupal and I will request a new fresh version. And then I will cache it until the Drupal tells me again that it has been invalidated. So that's a system that is only existing since Drupal 8 and 9 with the cache tag system. And that allows you to basically, any time when an editor goes in and saves something, you have the newest information immediately on the website publicly available for everybody. But like I said, that's quite a sophisticated system. It needs proper testing and it's handling. Our experience is we just do the 15 minutes. That's usually the case that people understand that, or we need to teach the editors that if they change something on the website, it can take up to 15 minutes to be shown on the website. Our experience is that 15 minutes is usually enough, or is enough fast to update new information, as long as it's not like hours or days where old information is in there. But if you have a case where you really need them within seconds available, there are possibilities to do this. All right, I think we're over time already. I wish you all a really good GovCon, or sorry, a government summit. We're not the GovCon yet, government summit. And yeah, hope to see you and enjoy your day. Thank you.